You gonna do all three, or is there anyone I can start on? You got the first two? Alright. I'll do the last two. 5 to what power gives you 125? 3? Okay, so log base 5 of 125 is 3. What happens with natural log and e? Cancel. So you're left with the exponent. So that's equal to 54. And then Miranda will walk you through these two. That's okay, I'll walk you through it in a second.
Okay, so
So, vertical asymptote 2 looks good, but why is 3 and negative 7 not 1? Because they are
because they're holes.
right. So you want to cross off the 3 and the negative 7. Get rid of those two. All right. So good. If we go down to the hole real quick, you're good with the 3, but your 7 should be a
-7.
Now, when Miranda was checking the horizontal asymptote, she's right. I see you got the x cubed from right here. X, so x cubed, right? X, so x cubed in the denominator. But what's in front of both of those x cubes?
Oh.
So that's actually going to be your horizontal asymptote. There you go. Other than that, nice job. Yeah, got all those. Let's get started on that one.
Oh, 81. Divided by 3 again.
Say it again.
What's 81 divided by 3?
81 divided by 3, what's that, 27? 27. Overall good, and I'm going to fix a couple things, but overall give it up for Miranda. And Miranda, make a note on Schoology so I can remember it, so I can get you your points. I think there might be one other person in here who has come up and I haven't gotten you your points. So if you've already come up and I haven't given you your presentation points, make a note on Schoology. But don't try and trick me because I have a good memory. All right. Let's see. So a couple things to fix here. This one should be x minus 9x plus 3. So that would be positive 9, negative 3. Agree? And then there was one thing you cannot do, which is right here. You cannot divide by x because there's a possibility that x could be 0. So you cannot divide by x. What you would have to do is factor out x. So you could not do this, but you could do this. X times, we already factored out the 3, so it's x times x squared minus 6x minus 27 equals 0. And like Miranda showed us, this part factors into this part, or this part. So then I have x equals 0 as well. So there were 3 zeros. X equals 0, x equals 9, x equals negative 3. Is that what you got? Okay. All right, good. So we're going to start trigonometry today. And here's a little funny comic about some angles. Hey baby, what's your sine? Have you've done a little bit of trigonometry already, right? All right. So we're going to use right triangle trig. Homework is going to be on Schoology, and it's due Wednesday. And yeah, you've done some of this, so should be some review. All right. Understand and use trig ratios to solve application problems. Okay, so tell me some of the trig functions you remember. What are some of the trig functions you remember? Because there's 6 of them that we're going to use. You should know 3 already. Okay, sine, cosine, tangent, right? So those are 3 that we should know already. So if you take sine, if you copy down this triangle here, and make sure you have everything in the correct place, all right? Otherwise it will not match up. So I'm going to pretend like you don't know anything about it so we don't leave anybody behind. So there's going to be a little review at first. Theta always aims at what side? Opposite, adjacent, hypotenuse? You all remember? Opposite. Okay, so this theta always looks at opposite side. The next easiest one to find, well, the first easiest one to find is the hypotenuse. The right angle always points at the hypotenuse. And then that leaves us with adjacent. All right. That's helpful because these trig functions are defined in terms of these sides, opposite, adjacent, and hypotenuse. So sine of theta, do you remember? How is it defined? Opposite over hypotenuse. Does that ring a bell? Yeah. Sine is opposite over hypotenuse. So we labeled our triangle. So for this triangle, sine of theta is 4/5. 4/5. Cosine of theta. Anybody remember how that one's defined? Adjacent over hypotenuse. So for this triangle, cosine of theta is 3/5. Tangent is defined as opposite over adjacent. And so for this triangle, it would be 4/3. So when you take sine, cosine, tangent, all right, you're just going to get a number back. You're going to get a number back, right? 4/5, that's a number. 3/5, that's a number. 4/3, that's a number. Okay? It's comparing the sides. All right. Now, there are 3 new ones that maybe I don't think you've learned before, and they're related to these up here. Sine, if you take the reciprocal of it, all right, it's going to be called something named cosecant. Cosecant of theta. I would draw an arrow from sine because they're related. Cosecant of theta is just the reciprocal of sine. The reciprocal, so that means it's 1 over sine. If it's 1 over sine, then it's what over what, if you're going to write it as a ratio? Yeah, it's 1 over 4/5, or just take 4/5 and flip it, right? Hypotenuse over opposite. So like you said, Ryder, yep, 1 over 4/5 turns into 5 over 4. Okay, cosine is related to this guy right here, secant. So secant is 1 over cosine. So tell me it's what over what? Hypotenuse over adjacent. Hypotenuse over adjacent. So for this triangle, all you have to do is take cosine and then flip it. So that means this one is 5/3. Good. Last one, the last new one is cotangent. Cotangent, C-O-T, cotangent of theta is, well, it's 1 over tangent. Tangent was opposite over adjacent, so cotangent must be, you got it, adjacent over opposite. So for this triangle, that would be 3/4. All right, good with that? So you give me these names again. This one is called what? Let's all say it together. Cosecant. This one? Yeah, it depends on how you pronounce it. Secant. Right? You can call it secant, I don't care. This one? Cotangent. Alright? And this guy right here is called what? No, I'm looking at the angle. Theta, right? So that one's called theta. Okay? So know how to say these things because it makes math easier if you can read. Alright. So those are the 6 trig functions. And now, you practice, okay? Find me sine for each of these triangles. Find me sine, cosine, and tangent for each of these triangles. So I'll give you about 3 minutes to figure that out. You're just going to do what we just did. And if you want, do cosecant, secant, and cotangent as well. But you don't have to. When you're doing these problems, your first step is always going to be to label. You're going to simplify your answers. Okay, so there's the first one. Give you another minute or two for the other two. Let me know if you need any numbers read off. I know some of you are kind of far back there. Okay, for the second one, what did you get for sine of theta? Second triangle, what did you get for sine of theta? 12 over 13, good. What about cosine? 5/13 and tangent? 12/5. All right, so good. So we got those down. So if you have trouble with this, just always remember to label first. It makes your life a lot easier. All right, so do you have any questions about these, finding these values? We're good with these? I don't see any hands, so I'm saying we're good. All right. You just did that, so that tells me you can do this. If you're going to find cosecant, for example, of, let's just go back to make sure you could do this. If you're going to find cosecant of this one, what would cosecant be? Okay, what about secant? 13/5 and cotangent? Okay, so we got this, right? All right, so good. Got that. Have you heard about angles of depression or angles of elevation before? Yeah. Oh, some yes. Sounded like a bunch of yeses. Well, good. So let's just recall what it is. Okay, you have your eyesight, right? Straight across. This one would be an angle of depression. This one would be an angle of elevation, right? So elevate, depress, right? Elevate, depress. So easy as that. Let's try on this one. You guys tell me how tall is this little ski ramp going to be? Use what we just did. Tell me how tall is this ski ramp going to be? All right, so give it a try. So work together too if you're not sure. And you'll probably want a calculator for this one. And you'll probably want it in, let's do degree mode. Well, I'll be in degree mode. So we all have the same answers. to get to degree mode, let me know. You have your graphing calculator up? Okay. So you want to click on mode. You want to go down to where it says third one down. Scroll to the right. Scroll over to the right. Okay, everybody in degree mode? Okay. Well, then solving this one, let's see, I should probably label. I want to know what this one is. Well, directly across from that angle is the opposite side. This one is directly across from the right angle, so this has got to be the hypotenuse. And I think to myself, what involves opposite and hypotenuse? And you say sine, right? So I set it up. Sine of 15.1 is equal to opposite, which is h, over hypotenuse, which is 19. If I don't want to round, right, if I just want to get an exact answer, multiply both sides by 19 over 1 to cancel the 19. 19 over 1. So then I know that h is going to be equal to 19 times sine of 15.1. And if we make sure we're on the same page here, I'm going to go to mode, make sure I'm in degrees. 19 times sine of 15.1. What'd you get? 4.94? Yeah, if you want to round it to the nearest hundredth, we'll say 4.95. Everybody get that? Yep. All right, and we're talking about feet here. H is roughly 4.95 feet. All right, so that one's pretty straightforward, right? Yeah. So applying it, easy application there. Okay, so now let's see, without a picture, if you can draw your own picture. Biologist whose eye level is 6 feet above the ground measures the angle of elevation to the top of a tree to be 38.7. They're standing 180 feet from the tree's base. What is the height of the tree to the nearest foot? So again, come up with your own picture. They're 6 feet off the ground. They are measuring an angle of elevation, 38.7, and they are 180 feet from the tree's base. See if you can draw a picture for that scenario, and then solve it. How tall is the tree? So does that picture look about right? The important thing here is to be able to calculate how tall this tree is. You have to take into account the fact that their eye level is 6 feet above the ground. So whatever answer we get for x, we're going to do what to it? Add 6, right? Okay. So if you solve this, this looks like it's going to be tangent because we have opposite here, opposite, and we also have adjacent being 180. So that means tangent of 38.7 is equal to x over, let's see, 180. So that means x equals tangent 38.7 times 180. And what'd you get for that? What'd you get for that? 144.20. Yeah, if you round it to the nearest hundredth, 144.21 plus 6 feet. So we should have got 150.21 feet tall. Good with that? Okay, if you add the 6 in, add 6. Tree is 150 point, it said round to the nearest foot, so we're just going to say 150 feet tall. All right, so is that one good? Yeah? No questions on that one? All right. Then, probably the most complicated thing we're going to do today is special right triangles. Do you all remember special right triangles? Yeah? What are the two special right triangles that we want to know? Yep, Owen? 30, 60, 90. And then the other one, 45, 45, 90. These ones are so special that you need to have this memorized. Okay, so get this into your notes if you don't remember it, because we need to know these ones by heart. I will not give you this. And I wrote an easy way to remember this on the board. For the 45, 45, 90, the only thing you need to remember is that the hypotenuse is square root of 2 times a leg. Square root of 2 times a leg for the hypotenuse, 45, 45, 90. For a 30, 60, 90, well, you're given the shortest side is a. The long side is a times square root of 3. The longest side, the hypotenuse, is just 2 times a. So if you remember this, all right, shortest 30 degrees, a. Medium size 60 degrees, a root 3. Longest side, hypotenuse, that's 2 times a, and that goes to the 90-degree angle. Good with that? All right, and let's try and use that. All right, let's see what examples we have here. Everybody have this page down? Good to go? All right. All right, so let's find out what sine, cosine, and tangent are for these special triangles. So let's see, for this one, I want to know what sine of 45 is. And I want an exact number. Well, you tell me. Does it matter which angle I choose? No, they're both 45. So let's see. 45 opposite is 1, so it's 1 over hypotenuse. That's, yep, 1 over square root of 2. Well, most people don't write square root of 2 in the denominator, so we're going to have to rewrite that. So we're going to have to rewrite that. Times the top and bottom by square root of 2 Well, so up top, you're going to have square root of 2. What's square root of 2 times square root of 2? 2, right? So sine of 45 is square root of 2 over 2. That's an important number that you're going to come to memorize over time. Cosine of 45. Let's see what that one is. Cosine of 45. Well, that's equal to adjacent over hypotenuse. So that's going to be what? It's going to turn out to be the same thing, right? Yep, because it's 1 over square root of 2. And that's the same thing like we just saw as square root of 2 over 2. And let's see, what's tangent? Let's find out what tangent is. Tangent of 45. Well, that's opposite over adjacent, right? So it's just 1, right? 1 over 1. And that's just equal to 1. So these are special numbers that we're going to have memorized by the end of the school year. All right. Let's go down here and do it for the 30, 60, 90. Is everybody good on this one? Okay. 30, 60, 90. Let's do sine first. Let's do sine of 30 and sine of 60. You give me the numbers. For 30, it's what over what? Yeah, opposite over hypotenuse, right? Opposite over hypotenuse, so it's 1/2. All right. Sine of 60. Opposite over hypotenuse, so it's square root of 3 over 2. Is everybody good with how we got those numbers? If not, you need to ask. This is the foundations. Okay, now let's do cosine of 30 and cosine of 60. Sorry, cosine of 60 and cosine of 30. Let me reorganize that. Cosine of 30, cosine of 60. Cosine of 30. Well, cosine of 30 is adjacent over hypotenuse. So that is square root of 3 over 2. Cosine of 60, adjacent over hypotenuse. So that is 1/2. All right. Everybody good on those? Okay. Tangent of 30, tangent of 60. Opposite over adjacent for 30. So that's what? Let's wake up. 1 over square root of 3. 1 over square root of 3. If you simplify that, what's that going to be? Square root of 3 over 3, right? Square root of 3 over 3. Okay, so we got to be able to rationalize denominators, which is what we're doing. Tangent of 60, so that is opposite over adjacent, so that's just what? Square root of 3. Opposite, adjacent, square root of 3 over 1. Okay? Good with that? If not, you need to ask. Right? This is the foundations. This is just the beginning. Well, we've used all this time, so we might as well use a little bit more. Let's see. All right. Find the value of x. Let's just, actually this will be good because I don't even think we need to use We don't even need to use really much math. This is what kind of a triangle? 30, 60, 90. That's important to see. Okay. They gave us the, you fill in the blank. They gave us the what side? Shortest side. What's the length of the medium size? What's the length of this side? What would be the length of this side? Don't give me a number, but what would it be? X square root of 3. What would be the length of this side? 2x. So what's the value of x? 37? Yep. 2 times something is 74. That something must be 37. Do you see how we did that? Yep. 2 times something equals 74, so that something must be 37. All right, how about this one? This one is a 45, 45, 90. They gave us the hypotenuse. Well, hypotenuse in a 45, 45, 90 is equal to what? Square root of 2 times leg. So this is equal to square root of 2 times x. So what's x equal to? X is equal to 20 divided by square root of 2. And we're not going to leave that square root of 2 in the denominator. We're going to rationalize times square root of 2 over square root of 2. So that's 20 square root of 2. What's in the denominator? 2. Well, what's 20 divided by 2? 10. So this is equal to 10 square root of 2. Do you see how we did it? Okay. We have to know the relationships for these special right triangles. If not, you're going to have a hard time solving these kind of problems. All right? All right. So I think we made it through. Do you have any questions before I tell you last thing? We all good? Yeah, Mariana? Tell me one more time. Well, so that's what it was, right? Hypotenuse is square root of 2 times short leg, right? And then I divided by square root of 2. Okay? Then, tonight, don't pay attention to that homework. This is your homework, and it's due Wednesday on Schoology. And you'll get instant feedback, and I think you have 2 or 3 times at it. So, right? So some good practice on there.